So hey everyone, today's lesson will be on squares. This is the first part of our series on the more broader topic of powers. We'll be learning about the most basic form of powers, which is squares. So, in particular, we'll learn the definition of squares, how it relates to bod mass, and we'll do some reasoning, which as well exercises as well, which means first showing that sum of squares is not equal to squares of sums. I'll be going over this soon. But also we need to show that the product of squares is actually equal to squares of products, which is also an important property we're going to learn. So, first of all, with definition of squares. Okay, a number squared looks something like this. You put a and then you put 2 with 2 at the top right of it, I guess. And all this means is the number multiplied, or two a's multiplied together, right? So a squared in words would be 2 a's multiplied together. So for example, we have 5 squared equals 25. So equals 5 times 5, which is 25. And in fact, you should be able to memorize all the squares until 15. And when I say memorize, don't just rote learn it. I would recommend to do them by hand 2 to 3 times. So if I tell you what 14 squared is, you should know that it's 196. But I don't want you to just know that by memory. I want you to have done this multiplication a few times. And just knowing the basic squares is very important, because spotting squares becomes an important skill later on. But anyway, let's jump to some more interesting examples. So the first skill we want to do with squares is we want to use squares in arithmetic operations. Sorry, in arithmetic expressions. Right, so what this means is, I'll give you an expression like 2 times 8 minus 3 squared plus 5 times 7 squared. You should be able to solve this while following the rules of bod mass. So in bod mass, what do you do first? You do brackets first. B is brackets. I know that some different schools teach different systems, like bod mass is what I usually use, which means brackets. Order is powers. D and M stands for division and multiplication, and A and S stands for addition and subtraction. Key idea is you do brackets first. So whatever's inside brackets, you do that first. So here, it's brackets first, so you do that first. So you do 2 times 5 squared plus 5 times 7 squared. And 5 squared is 25. Sorry, let's slow down. Then once I get to that, I've got to do check if I have any more brackets left, and I don't, so I go to the next part, which is order, or if it's E, it's exponent, or you have B, bit I for indices. Whichever letter you use, doesn't matter, they all mean the same thing, they all mean the power. So 2 is a power, so you do that first. Sorry, squaring is a power, so you do that first. Times 25, 5 times 49. I guess the question is, why is BODMAS defined this way though? Well, it's because realistically, okay, why is this? That's a pretty deep question. There's no like simple answer. The idea is addition, multiplication, all these operations are, functions. Means they take an input and they return, put it into the function, give an output. So if we were to use this like function notation, then it would all make sense. You could think of addition as taking in two numbers, 2, 3, and then returning 5, right? So you could say addition of 2, 3 equals 5. Similarly, multiplication of 2, 3 would be 6. Now, if we were to write this in this function notation, you don't need BODMAS. This would be multiplication of 2 and 8 minus 3 squared is square of 8 minus 3. Square of, I'm going to say S is subtraction, S of 8, 3. And then this is all being added together. So you could write this in some function notation, and you're probably confused by now. And this is weird, but the idea is, although it's weird, the order is super clear. But as you can see, first of all, you need the prerequisite knowledge of functions. Which is already a pretty complex topic. And you also need to just write this horrible notation. It's just long and ugly. So that means this notation is not really viable for us initially. And it's actually, although it's probably the more correct notation, it's not that nice. So it never gets used. Instead, we want to avoid this notation, so we come up with a set of rules for writing expressions that we tend to follow, so that we lose some of that complexity, but then we get a very slightly vague system, because we don't know which one to do first. And we give ourselves these rules to figure out what we do first. And by giving ourselves these rules, we can get the right answer still without worrying about this ugly notation. That's all it is. It's just a rule to have some order. Because, again, we need to do things in order, but we don't know what. And, something like this notation will make it very clear what it is, but it's ugly. So instead, we use this nicer notation that's a bit less clear, and instead give some rules to follow for this format. That's why BODMAS really works. Anyway, we got sidetracked. Let's actually come back. Let's reset. So yeah, we got 2 times 5 squared equal plus 5 times 7 squared. And 5 squared, as you know, is 5 times 5, which is 25. So it's 2 times 25 plus 5 times 7 squared. 7 squared is 7 times 7, which equals 49. That's 5 times 49. 2 times 25. Oh yeah, sorry. Let me slow down. Done I. Now we're going to do division or multiplication. Division here would be, there's no division. We've also got to look for multiplication. 2 times 25 is 50. 5 times 49, let's do that. It's slower. 9 times 5, 5, 4, 24, 245, which equals 295. So 295 is our answer here to this expression. And we just got to be comfortable following this order around when we do this. Our next skill we want to have is where we've first done definition. Then we've done some BODMAS work with squares. And finally, we'll get to some reasoning now. The third thing is sum of squares is not equal to square of sums. And the reason this is important is because this is a super common mistake that so many people make. So my question for you is this: what's a plus b squared? If you just give it as a shorthand, would you say it's a squared plus b squared? Seems obvious, right? But it's actually not. This is not true. This is actually wrong most of the time. Some very small exceptions. This is the fundamental theorem, a fundamental result. Why is this true? Think of an example. Uh, 3 plus 4 squared. Suppose this was 3 squared plus 4 squared. What would that be? 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. I mean, this is 25. But we also know by BODMAS, if you do the bracket first, we get 3 plus 4 is 7. 7 squared. So we're saying 7 squared is 25. But if I calculate 7 squared separately, I also know 7 times 7 is 49 equals 25. Clearly this is false. As you can see by this example, is not true. Now, why is this? Why are they not equal, though, right? So this is just an example that shows that it doesn't work. So we know it doesn't work, but why? Well, the reason why is actually we need an idea, which is called the distributive property. Have you guys heard of the distributive property? Distributive property is just a property that says you can distribute multiplication to individual terms inside bracket. I have 3 times 5 plus 3. Now, of course, this is very easy. This is 3 times 8, which is 24. So this is a very easy example, but just pretend the long way that I'm going to do is not the most efficient, but it's just there to show the distributive property works. What it says is 3 times 5, you can do it like this. 3 times 5 first, this times this. And then you do this 3 times this second term next. It's 3 times 3, which is that. And then it's 15 plus 9, which is 24. So you get the same answer by doing it this other way using the distributive property. And that's the key, one of the key ideas of multiplication. Sorry, one of the key properties of multiplication. In general, if you have a times b plus c, what it says is this is equal to a times b plus a times c. So let's use this prereq to get to our answer. So let's think of a plus b squared. What's that equal to? Well, by definition, this is a plus b times a plus b, right? That's the definition of squares. And we know here that it's too big. Okay, that we can distribute. We can say, I can multiply this entire thing by this. By the first term in the bracket, so it's a plus b times by a. And I can do the same thing. This a plus b can multiply with this second term. A plus b times b. Then I'm going to use the commutative property and switch these around. It's a times a plus b times a plus b. And then I switch it again. It's a times a, which is a squared. Sorry, let me slow this down. Then once I commute, I switch them around. I do distributive property again. I do this times this, and this times this, and same for the second bracket. And I get a times a plus a times b plus b times a here plus b times b. This is just the distributive property again. And look at these two terms. What's a times a? By the definition of squares, this is just squaring, right? Let's switch these two around, no problem. The same thing, plus b squared. So it's a squared plus b squared with these two extra terms. So it's not exactly a squared plus b squared. So that is how this property works. So what this means is you can't take this shortcut. Do not take this shortcut. This is a very common trap. Right? Don't fall for this trap. You don't understand the countless amount of papers I've read where people go, oh, 10 plus 1 squared, that's 10 plus 1 squared. Oh, that's 10 squared plus 1 squared. It's 100 plus 1. That's 101. It's not how it works, unfortunately. So please bear this in mind when you do questions. And finally, let's get to the final property of today, which is that product of squares is equal to squares of products. What if I asked you to do 8 squared times by 25 squared? Now, if you were to individually solve these, this becomes kind of ugly. 8 squared is not bad, 64. 25 squared is a bit annoying. But let's say you get through it. You do this, vertical multiplication. You try to get through it. And let's say you somehow do and end up getting the answer after a while. Which you probably will, but it just takes some time. Then you have another ugly multiplication scheme. And you have to do this. And it's just so long. But after all this time, you will get that the answer is 40,000. Now, this is the motivation for this property. The motivational question is, is there a faster way? Is it possible to be faster? And the answer here is yes. Unlike the sum of squares method, where you can't be faster, you absolutely have a shortcut here. So what you have here is product of squares. You square first, then you take a product of those squares. But if you do square of product, so you do the product first and then you square it, it turns out to be equal. Now, why is this faster? Take a look. 8 times 25 is 25 times 8. 0, 4. It's 200. It's 200 squared. And what's 200 squared? That's just 200 times by 2. Then you add 2 zeros. That's 40,000. It's super easy. It's just 4 with a bunch of zeros on top. A lot faster than just doing it directly. So you do end up getting the same answer. But again, we need to prove it. The important question is why? Why is this true? Well, here's the proof. You know that a squared what's our goal to prove? We want to prove that a times b squared equal to a squared times b squared. And here's the proof. Let's start with the left side, this side, a times b squared. By definition of squares, we know this is a times b times a times b. So this is just the definition of squares. How do we get to this though? Well, first of all, we can get rid of brackets. Why can we get rid of the brackets? Because multiplication is associative. It doesn't matter which order you do these multiplications in. It will be equal. But then after that, what we do is we switch these two around. Then you get a times b times b. Now you see how we're getting closer, right? And then again, since it's associative, we can also force any order we want. So let's say we do these two first, and then we also do these two on their own. So this is again associative, which basically means do multiplication in any sequence or like any order. right? So you can do, doesn't matter which multiplication you do first, right? And then after that, what's a times a? Well, that's a squared by the definition times b squared. So all this is saying is, I'm just using the definition of squares. And then I'm done. To prove that exponents work. So that's it for squares. That'll be the entire lesson here. Yeah, that's basically it. I'll see you guys next time. Hope you have a good one. Bye.